So this is a typical question that you see in this section of physics where you have to do a full calorimetry problem in trying to go from one uh, state to another to a final state. A lot of time they do this with water, but you see in some of the other examples, they do one with dry ice and the sublimation of dry ice, and then take one where they do it in terms of removing heat, which in those situations you would have a negative heat in the end. The way I like to do these problems is almost set up like a little timeline. Um, so if I'm doing the first example, talking about how much heat is needed to change the temperature from of a 0.05 kilogram sample of ice from negative 15 to 30 degrees Celsius. A lot of times what I do is I make this chart. The first temperature would be the starting temperature, and then the last temperature would be the final temperature. But we also have the phase change. So remember, water uh, melts or freezes at 0 degrees Celsius. So when you do this, you have temperature change, you have a phase change, and then here you also have another temperature change. So you have to find three heats. The big thing is that students will want to go from negative 15 degrees all the way up to 30 degrees in one MCAT equation, but you have to separate into three different heats: Q1, Q2 at the phase change, and then Q3 here um, in the final temperature change, and then it just becomes our total heat is just the sum of these three. So you have Q1 plus Q2 plus Q3. But the first thing we do is determine these heats so that we can plug them in. So the first one will be uh, ice, right, from negative 15 degrees to 0 degrees. Okay, so that will be an MCAT. So Q equals MC delta T. And one thing also to remember is that ice has a different specific heat than water that has, and then vapor has a different specific heat. So we have 0.05 kilograms. They give you the specific heat of ice is 2.05. And then we have a temperature change and we go final minus initial. So 0 degrees from 0 to minus negative 15. And we find in this section we add 1.54 kilojoules. Now we're going to do the phase change. So we have the phase change, right? So it's from ice to water. And this happens at 0 degrees Celsius. Um, so remember, the melting point or the freezing point of water is 0 degrees. And so now we're going to use our Q equals ML. And this happens to be the latent heat of um, fusion, so L sub F. And so same, again, make these assumptions that the temperature or the mass never changes. So we got 0.05 times the latent heat infusion, which is 334 kilojoules per kilogram. And we see that we get a heat added of 16.7. And that's what happens a lot. This is where you find most of the heat happening is at the phase changes. That's where most of the heat is added. The only time it will be probably a little bit higher for some of the other changes if the temperature changes from like 0 to 100 or 100 to 200 degrees. But most of the time at the phase changes, you'll see that because the latent heats often are bigger numbers. Um, so now we got water, right? And we're at 0 degrees Celsius. And we're going to go up to our final temperature, which is 30 degrees Celsius. You don't have to make these conversions because remember, change in Kelvin is also a change in Celsius. So if they give you the units of kilojoules per kilogram times Kelvin, it's the same thing for the temperature because it's a temperature difference, not an absolute temperature. So here we have another MCAT. So Q equals MC delta T. Again, 0.05 kilograms. The C for water is 4.186. And then we have a temperature change of 30 minus 0. And it's going to give us a heat added of 6.28 kilojoules. Sorry about that. And now all we have to do is go back to our original. All right, we said that the total heat was just simply the sum. So Q total is just Q1, which was 1.54, plus Q2, which was 16.7, plus Q3, which is 6.28. And so it gives us a total heat added of 24.5 kilojoules, or if we move it 3 spaces, 1, 2, 3, of 24,500 joules. Okay, or if you go through and do the conversion factor from calories to, so you have 24,500 joules. Okay, and then 1 calorie is 4.186 joules, which then tells us that it's 5,860 calories, right? Or 5.86 kilocalories, which are the food calories. So you just have to pay attention to what ultimately they're looking for. So these are all potential answers just based on, what question is looking for. So just pay attention. Remember this conversion factor here of 1 calorie equals, so 1 calorie equals 4.186 joules. You can even put that to kilojoules, but I would convert from kilojoules to joules, and then joules, the calories